Hi guys, Ms. Michelson here. Today I'm filming a video going over the not topic 3, the Common Assessment number 3 review. So this is our third test from the district. This is just the review assignment to help get us prepared and warmed up and ready for those types of questions we're going to see again. So I've got my review pulled up on my screen, but you guys should have it out on paper in front of you. And I've got my Desmos calculator ready to go. And my first question here is my segment addition postulate. So we're remembering small plus small equals big. So they tell me if the length of AC, this whole thing, is 38, what is the value of x? Well, we know that this left side is 3x plus 4. We know this right side is 5x minus 6, and the total equals 38, and we should get that total when we add those two values together. So we just are going to combine our like terms. I have a 3x and a 5x. When I add them together, I'm going to get 8x. I have a plus 4 and a minus 6. When I subtract those, I'm going to get minus 2 equals 38. And now I've got my equation ready to solve. I'm going to add 2 to both sides to move that 2 over. I'm going to be left with 8x equals 40. And then our last step is always going to be to divide by that coefficient out in front of x. I'm going to divide both sides by 8, and we are going to get that x equals 5. Number 2, this comes from topic 2 with our parallel lines cut by transversals. It says line P intersects lines A and B, and if A and B are parallel, by which theorem is 3 congruent to 6? So remember, we were labeling these, this is so long ago, we were labeling these our exterior, our interior, and our exterior, and I noticed that both 3 and 6 are in my exterior, so it can't be my interior angles theorem. And then this option C, corresponding exterior angles, that wasn't one of our theorems. And hopefully we can see that 3 and 6 are on alternate sides of that line P, and they are both in the exterior. So A is my correct answer. And I'm going to scroll down, and forget how to clear my screen. I'm going to scroll down and move on to question number 3. This comes us back to topic 1. What is the hypothesis of a conditional statement? If two angles are vertical angles, then they are congruent. We remember the hypothesis goes with the if statement. So if we locate that, then what follows after it is our hypothesis. My hypothesis is two angles are vertical angles. Question number 3 says fill in the blanks. Parallel lines are in the same blank, but they do not blank. So I like this part of the question a little bit better here. What do we know about parallel lines? They never, ever, ever intersect each other. So that's kind of our definition of parallel. This blank right here is just a little formality. Parallel lines have to exist in the same plane for them to kind of like even be able to exist or intersect each other, which they don't. But they have to exist to kind of in the same world. So they're on the same plane, but they do not intersect each other. Question number 5 is going back to I'm actually going to slide this up a little bit. It's going back to what we know about our straight angles. We call these two angles, both sides of my straight angle, a linear pair because they form together to make a line. And we know that a straight angle measures 180 degrees. So when I add those two angles together, 5x plus 10 plus 2x minus 5, this should equal 180 degrees. So we're going to combine our like terms just like we did with number 1. 2x and 5x is 7x. 10 minus 5 it's a positive 10, so it's a plus 5, equals 180. We're going to subtract 5 from both sides, and I'm going to come over here. 7x equals 175. And our last step is going to be to divide. And I have my Desmos calculator pulled up on my computer, but I'm going to use my handheld one. Divide both sides by 7. And I don't think we're going to get a pretty number here. 175 divided by 7. Oh, I lied. That equals 25. Now, was the question asking me to find x? It wasn't. It was asking me to find the measure of ABD. That's this blue angle right over here. So one last step is we got to take this value of x and we got to plug it back in to our expression over here. So we're really going to solve for 5 times 25 plus 10. Well, I know if I have 5 quarters, I have $1.25. Plus 10 would be 135. Is going to be the measure of that angle. And the number 6 is really similar, except for we're dealing with the triangle this time, but our setup is very, very much the same. We know that all of the angles in a triangle, when we add them all together, it should equal 180. So I'm going to take 2x minus 10, and I'm going to add 4x plus 10, and I ran out of space, so I'm going to put my 4x over here. So all 3 of my angles, if I add them all together, this should equal 180 degrees. So now it's just an exercise again of combining our like terms. We have a 4x, a 2x, and a 4x. If we add them all together, that's going to give us 10 x's. We've got a minus 10 and a plus 10 that are going to cancel each other out. So we have 10x equals 180. I'll divide both sides by 10. And we will get x equals 18. And we were really trying to solve for x that time. So all is well in the world. X equals 18. Number 7 is just a little test about our transformations. We did our whale project for this unit, or our transformation project. The rigid, or what is the rigid motion transformation? Oh gosh, I read that wrong. What rigid motion transformation maps the solid line figure? Why can't I read this? What rigid motion transformation maps the solid line figure on figure? Okay, that's not my mistake. That's just written poorly. But basically, we get the gist of the question, right? We're trying to figure out how do we go from this dashed line to this solid line, or vice versa. And hopefully I can see that if I visualize folding my piece of paper in half on this line right here, we've got a mirror image of each other, which means that this is a reflection. I reflected across that red line right there. All right, moving right along, page number 2, we're trying to find the measure of angle QPR. Q to P to R, that's this right here. We don't necessarily need this extra triangle then if we're only dealing with this angle measure here. So I'm going to actually redraw my picture. And I know that this is 68 degrees, and I'm trying to find this right over here. I am also told that these two sides are congruent to each other, which means this is an isosceles triangle. Isosceles triangles have congruent bases. So my 2 base angles are the same. And then we can go ahead and solve for this. So the one thing that I know about a triangle is that the total should be 180. So I'm going to subtract what I'm given. 180 minus 68. I should be able to do that in my head, and I can. Sometimes I just get nervous. So we've got 112 degrees. But 112 degrees has to be split between 2 congruent angles. So I'm going to divide that by 2. So that's going to tell me those 2 base angles there are both 56 degrees. The measure of QPR is 56 degrees. Number 10, I should have moved my face over here. Number 10 asks me, by which theorem can you conclude that these 2 triangles are congruent to each other? So I'm looking at my list: angle, angle, side, side, angle, side, 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 hypotenuse, leg. And all of those are valid. All of those are viable options. But we got to see what our picture is telling us. So the first thing I notice is we've got 2 right angle boxes. And when I see right angle boxes, the red flag that goes off in my mind is it might be hypotenuse leg. So we got to check, we've been practicing right triangles over the past couple of days, whether or not my hypotenuse and my legs are marked. Well, this is my hype and this is my hype. They're both marked, so that's good. And this side right here is the leg of either one of my triangles, the left or the right one. So we have the conditions for hypotenuse leg. We are halfway through, 10 minutes in, rocking and rolling. Question number 9 says to show that JKL is congruent to LMJ by angle side, what must be the value of X? Well, congruent means that all of those pieces inside this theorem right here are congruent to each other, which means my two angles have to be congruent. And what does it mean to be congruent again? It means they have to be equal to each other. So I'm going to take my two expressions and I'm going to set them equal to each other. 2x plus 18 equals 3x plus 12. If you are one who likes to keep their work organized by drawing this line right here, you can do that. I first noticed that I have an x on both sides of my line, so I need to move the smaller one over by subtracting 2x from both sides. So I'm going to get 18 equals x plus 12. And then I'm going to subtract 12 from both sides to get x by itself. 18 minus 12, that's about 8. 18 minus 12 is 6. So x has to be 6 for those two triangles to be congruent to each other. And then our next one says find the length of DF. Hint, solve for A and plug it back in for FG and DG. So to solve for A, we got to figure out what the relationship is between these two values right here. And I notice that my two triangles have these markings on them. They have a congruent angle, they have a congruent side, and by the reflexive property, EG is congruent to itself, which basically is just a long explanation for me to say these two values are congruent to each other. 4a equals a plus 9. So let's go ahead and solve for a. Again, I have a on both sides of my equation, so I'm going to subtract 1a from both sides. I'm going to get 3a equals 9, and then I'll divide by 3, a equals 3. Now we can't stop there because we were trying to find the length of this entire segment. 3 times a is 12. A plus 9. So 3 plus 9 is also 12. So the total or the length of all of DF is going to be 12 plus 12, which is equal to 24. 24 is my answer there. Moving right along, number 12 says list the sides from shortest to longest, and it gives me a nice hint. I have to find the measure of angle C first. So I'm going to take the two numbers that they give me and I'm going to add them together, 145. And then I'm going to take that number and I'm going to subtract it from 180. So that's going to give me 35. The measure of angle C is 35. And then remember that across from the smallest angle is the smallest side. So AB should be my smallest side. So it should go first. So I can go ahead and mark off A and C because those aren't going to work. Then my next highest number is 62. Directly across from 62 is BC. So I'm looking for the one that goes A, B, and BC. That would have to be B. A triangle has two sides with lengths 20 and 42, which best describes the length of the third side. The third side is either going to have to be when we add them together. 20 plus 42 is 62. It's got to be less than 62, but it's also got to be greater than when we subtract them. 42 minus 20 is 22. So greater than 22, but less than 62. If you want to make yourself a note, Here we subtracted those numbers, and here we added those numbers. Number 14, I see a polygon. It says find the value of A, and A is this missing angle right here. We need to first find the sum of the interior angles of the polygon. So our formula here is that our sum is equal to 180 times, in parentheses, n minus 2. That makes sense. So n is the number of sides I have in my figure. 1, 2, 3, 4, 5, 6. So it's going to be 180 times 6 minus 2, which is just 180 times 4. So my sum, or my total, of this polygon over here should equal 720. But I can use that information to help me find this missing angle. So I'm going to take all of these numbers here. I should have switched my color. And I'm going to add them all together. So 107 plus 105 plus 125 plus 126 plus 127. And I want to add all of those up in my calculator. 107 plus 105 plus 125 plus 126 plus 127. This equals, when we add them together, 590. So to find our missing angle, all we have to do is take our total and subtract what we're given. 720 minus 590 is 130 degrees. All right. Our next one, what is the measure of one interior angle of a regular 18-gon? Hint again is first to find the sum of the interior angles. So the sum is equal to n minus 2 times 180. I wrote that backwards from our last one. And n represents the number of sides, which is 18. So it's going to be 18 minus 2 times 180, and I'm going to do that in my calculator. That would just be 16 times 180, which is 2,880. Now that is the total measure of this 18-sided polygon, all of the angles added up together. However, if we want to find one single one, our last step is to divide that by n, the number of sides that it has. So we have to take 2,880 and divide it by 18. So that tells me one singular angle has a measure of 160. All right, I am back. It is a new day. We are starting on, oops, that's not my pen. We are starting on number 16. And I like this question, but it is a little bit involved because we're trying to find the perimeter of this triangle right here, which means we need to know what all three side lengths of the triangle are. So I'm looking at from X to Y, and I notice that I don't have that length. And I'm looking at Y to Z, and I also notice I don't have that length. I do know this little bit right here, and I know this little bit right here as well. So what I need to figure out is what these two question marks are. And one of the properties of our kites tell me that this is a right triangle. So if I draw my picture over here, I know one side is 6, one side is 8, and I want to find the third side. And this is something we've been practicing in class over the past couple of days. This is the Pythagorean theorem. A squared plus B squared equals C squared, where A and B are 6 and 8, and C is going to be my unknown, my missing value. 6 squared plus 8 squared is 100. That's 36 plus 64. And the last step to get C by itself is going to be to take the square root of both sides. The square root of 100 is 10, which means C has a value of 10 right over here. Now we're going to do the same exact problem, but now for this bigger triangle down here at the bottom, it looks something like this. We know this side length is 15, and we know this side length is 8. So again, we're trying to find the hypotenuse. So we're going to say 15 squared plus 8 squared equals C squared. I don't know that one off the top of my head, but I got my calculator nearby. 15 squared plus 8 squared is 289. 289 equals c squared. And I want to take the square root of that. And that tells me that c equals 17. So that means this is no longer a question mark. It's 17. So if I want to find the perimeter, I'm going to take 6 plus 15 plus 10 plus 17. So if I add all of those up in my calculator, 6 plus 10 plus 17 plus 15, the perimeter is equal to 48. 48 units. Now, question number 17, we have a parallelogram in our picture. And what we want to remember from our parallelograms is that their opposite sides are congruent to each other. So I'm trying to find x and y. So the first thing I'm going to do is cross these two values out because I don't need them. That had a z in them, so I don't need to find it. But we do know, kind of like our rectangles, that these opposite sides are congruent to each other. So we have to think, what does it mean to be congruent again? Congruent means that they are equal to each other. So we just have to set up two equations and we have to solve them. These ones are kind of like ones we've seen before in this review, where we have to move our x term to the other side of our equal sign. So I'm going to get 4 equals x minus 3, and then I'm going to add 3 to both sides, and I'm going to get x equals 7. So I'm going to plug in a 7 right down here. And then we have to do the same thing, but we have to do it for y this time. So y is my opposite two sides, but same approach. We're just going to take 2y plus 10 and set it equal to 3y minus 2. And then we have to solve by moving 2y to the other side of my equation. 10 equals y minus 2. And then I'm going to add 2 to both sides. Y equals 12. So we can plug that in. Y equals 12. All right, just a couple more to go. Our next one is a multiple choice question. It says, which statements are properties of rectangles? So it looks like I'm going to select all that apply here. And this is something that we did before winter break. But our properties of our rectangles are as follows. We know that rectangles have opposite sides that are congruent to each other. So I'm going to select E. D says all 4 sides are congruent. That is not true. A through C are talking about these diagonals that cut through the corners of my rectangles. And these diagonals are congruent to each other, but they are not perpendicular and they're not angle bisectors. All of the ones we crossed out are properties of squares, not rectangles. Number 19 says which additional piece of information would show that ABCD is a rhombus. A rhombus basically has all of those properties that we crossed out up above as well. So AE equal to EC. We already know that because that's true about parallelograms. AD is parallel to BC. We already know that because that's true to parallelograms. AB is congruent to DC. That is also true for parallelograms. But the one thing on here that sets this apart as a rhombus is C. A rhombus has diagonals that are perpendicular to each other. So that's going to be my piece of information about my rhombus. And then my last one is going to be just defining this shape given its picture and its numbers, which is the most precise description of this quadrilateral. This one I see is a little bit funny because it doesn't look like my lines are parallel to each other, but I do notice that I have these 2 legs that are congruent. And I do notice also that this point is the midpoint right up here of my figure. And with those 2 characteristics, this is what we're going to describe as a kite. And that's going to be the end of my video. Sorry that there was a little blip there in the middle, but you all are good now to go ahead and start working on your Common Assessment on Canvas.